So you ready to get started?
Yeah, I'm trying to
Pull up.
minimize this thing here.
And we have to upload this, right?
Yeah, hit live, I guess.
Okay.
Okay, so I've got this up. I've got this up. So, you ready to try and get this started?
Yep. I'm pulling it up right now. Lesson 13 quiz. Okay. So to distribution applet. Okay. So we're going to be using SPSS. How is SPSS working on your computer?
Yeah.
Okay, I've got I got VMware. I've used it a couple of times recently. I had to delete it and then re-download it. So it should be working for me tonight. Here we go. Okay, so when calculating anything, please remember to round. Okay, never mind. Okay, what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply.
I believe it's A and B.
Yep. So normally distributed, that just goes over, and then random. Yeah, so I feel like that one's just common sense if you get it. The test statistic for a hypothesis test comparing two means with independent samples is a
Gotta be a T-score.
yeah. You're like getting ahead of me. You're doing it quicker. All right, so two samples. So two samples are independent. Are independent if knowing which subject will be in group one determines which subject will be in group two. That is dependent, and knowing which subjects will be in group one tells you nothing about which subjects will be in group two. I feel like that one is B.
Yep, I'm with you.
Cool. So for the next 6 questions, use the data file dentistofficebills.save. This okay. So let's see. So perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null, and the alternative. Use the level of significance 0.10. All right. Have fun.
Okay, so okay.
Here, I'm gonna try and download, or not download, open it up. Okay, because I'm using the VMware, I have to go to the textbook. Give me 1 second.
Okay. So U1B, the mean bill, dental bills. Okay.
And what data files are we using? What is that one called?
It's called dentistofficebills.save, but it's not in the it's not in our normal folder. You have to click on here.
Dang it, I'm not gonna be able to open it then.
Okay.
Yeah, if it's in the files, I can open it. If not, it's just not. We'll have to download it and go to a different program. So,
Okay. Okay, so we've got perform a hypothesis test to determine if the mean bill at Idaho Falls is less than the mean bill at the Rexburg office.
yep.
Okay, so the hypothesis is office 1 is equal to office 2,
Mm-hmm.
and the null
Is that it is?
I don't know if it's less than. So it's a one-tailed test.
Yeah. Sorry. I think I'm out of accident. Just give me 1 second.
Okay, so let's go into, we have to do the transform and automatic recode.
All right, give me 1 second. I accidentally exited out.
So the variable is it's got to be the dentist bill. So the variable will be the dentist bill, not the city.
Give me 1 second. Let me read it. I'm sorry. I accidentally logged out or accidentally clocked out. Just gotta. We're at 5. Oh no. There we go. We're at 6. Cool. All right. So perform a hypothesis test. Okay. So the data. So what is the degrees of freedom? All right. Degrees of freedom are very easy to find out. I don't know if we.
Everything comes out of SPSS.
Okay. Okay.
I'm just working on see if I've got it right. Nope, that wasn't right.
Yeah, is there any way you can do screen share and I can just kind of walk?
Let's see, screen share.
It's you're not really looking for something. You're looking for the green little logo on the.
Yeah, I've got to just open up my window here a little bit bigger.
Cool. Yeah, and you don't even need to have me on the screen. You can just do just like the screen share. So kind of turn.
Okay, you got it?
Cool. Let me.
Okay, so get back into here. Okay. So I'm gonna start over again.
Okay.
And then I'm gonna get this thing up here. Okay, so this is the data.
Okay.
We want to perform a hypothesis test to determine if the average bill size in the Rexburg office is less than no, if the bill in the Idaho Falls office is less than the Rexburg office.
Okay.
So here we have, let's shrink this in. Come on. Do this. Okay. So here we have Idaho Falls, and then we have Rexburg. So those are the variables. So I go to transform, automatic recode.
Yep.
And then it must be the city is the variable because that's the one we're looking for the differences in. So let's try that.
So okay, so we're doing the automatic recode right now.
Yeah, automatic recount or something like that. It's called the automatic recode.
Recode, yeah.
Okay, so I did that So I get everything coded. One's for Idaho Falls and twos are for Rexburg.
Yeah.
Then I have to go to analyze it and then down to compare means for a one sample t-test. No, wait a minute. This is an independent sample t-test. So the grouping variable would be the city code and the dentist bill would be that. I believe that's it. Okay, so then it gives us this. Okay. So the question is, what is the degrees of freedom? The degrees of freedom is 37.996.
Okay, so I don't know if I don't know if I'm remembering it correctly or if I'm just mixing stuff up, but something tells me that that's not how you get degrees of freedom, but I'm not sure.
That's where you get it.
That's where you get it.
You get it off the test.
You get it. Okay.
Yeah, you don't have. There's no. I don't think we use the applet at all this time.
Yeah. Even the so the applet we used last time, we're actually not supposed to use it. The applet actually doesn't. Like if we're ever using the applet, then that means we're doing something wrong. That's coming directly from my what you call
Tutor.
it? Yeah. Okay, so I'm looking for the notes. The degrees of freedom is usually like it's like n-1.
N-1?
Yeah.
Well, in this instance, don't worry about it being not a whole number. You don't round it.
Oh, okay, cool.
You don't round it.
Cool. Then I'm not worried about it. If it comes up, if it's wrong, then it's wrong, and we can correct
We'll find out.
We'll find out. Yeah, that's the motto. We'll find out.
Number 7.
So what is it? So the degrees of freedom is that
37.996.
37.996, and we're going with the equal variances of assumed. So we're going with the bottom ones.
Yes, you only use the bottom row.
Okay, 37.996. All right, what is the sample standard deviation for Rexburg? Down to 3 decimals.
Okay, so for Rexburg, it's right here, 206.637.
206. What is the test statistic? That would be 0.434.
Let's see.
Oh,
Negative 0.434.
Okay, and what is the p-value?
That is this here.
And you half it, right?
Well, if it's a one-tailed test,
yeah,
I don't think you half it. It's only if it's two-tailed. Because you have to have one half for one tail and one half for the other tail.
No, I think. Wait, hold up. I think if it's so I don't think we half it this time. Is that what you're saying? Because
that's what I'm saying.
Yeah, because this is a two-tailed test we're doing. Right?
No, we're doing a one-tailed test.
One tail. Okay, so we do half it.
No. I only think you half it when you have a two-tailed because you have to get a number on the left tail and on the right tail, so you have to divide this, the p-value in half. but we're doing a one-tailed test, so we just leave it as it is.
Okay. And if we get it wrong, we know where we went wrong.
We will know.
Yeah, we will know. That's a good motto, I feel. All right. What is the correct decision based on the evidence? Okay.
Okay.
Before you answer, is it okay if I try to figure this one out? Because this one
Yeah.
I've been really struggling with. So let's just kind of like go through, pick an answer, and just tell me when you've got an answer.
Okay, I know what the answer is.
Okay.
At least I know what I think the answer is.
Okay. Okay. So I know how you make the decision. I just don't know on the exact like how it works. So
Well, if the p-value is high,
yes,
you
and
don't
it's
reject
higher
the
than
null.
or than alpha. So the p-value is higher than alpha, right? Or the level of significance.
Yes, it is. So we fail. I think we.
That's what gets me because I can get up to that point, but then I'm just like, is it fail to reject or reject?
Here's what I learned.
Okay.
If the p is low, you reject the null.
Okay.
If the p is high, you keep the guy.
P is high, keep the guy. Okay, cool. I can remember P is high, keep the guy.
Yeah.
Okay, cool. I like that. All right, thank you. So we failed to reject because we keep the guy.
Yep.
Cool. Suppose instead that you had used the alternative hypothesis. Alternative equals not, or mu does not equal, or 1 does not equal 2. What is the correct decision based on this evidence?
Okay, suppose instead you had used the alternative. Okay, so if you use the alternative, then you have to take this 0.666 and cut it in half. But it's still higher than the level of significance.
Okay.
So
that would mean we have. So you come up with an answer and then let me know when you're ready, because I'm gonna take a second.
okay.
Okay, I'm gonna. Are you ready?
Mm-hmm.
I think it's C.
I would agree.
Okay, cool. Cool. For the next 6 questions, use the data file, freshman, diner, or dinner. This data represents times freshman students from Utah and Colorado.
Okay, so let me open this up. Okay. Excuse me. Can you see my chart over here, the data?
Yeah.
So it represents the number of times freshman students from Colorado and Utah cook their own dinner. Okay, so mu1 equals Colorado
Mm-hmm.
cooks, and mu2 equals Utah cooks. Okay. You suspect that the freshmen from Utah cooked dinner for themselves a different number of times.
Okay, so that does not equal.
So that, you're right, that would be mu1 does not equal
So that would be
mu2.
B, correct? That would be B.
I don't know, I gotta look at the question first.
Okay, sorry. Getting ahead.
Okay, what is the question? What is the alternative hypothesis?
Yep.
So we're saying that
It is not equal to.
you're saying that the null hypothesis. Okay, so the null hypothesis is
Oh,
yeah.
hold up. Oh my God.
That's right.
No. For 12 is alternative hypothesis.
Right.
Yeah. So what is the appropriate alternative hypothesis?
So up top, it gives us the null hypothesis.
Yes, the null hypothesis is that they equal the same.
Right. So when it says a different number, that doesn't say less or more. It means a different. So it means
not equal.
Could be less or could be more.
Yes. And
so I think it's.
So
which one do you say it is?
That's why I'm saying B, because it does not equal to. So it's,
I would agree.
Okay, cool. Cool.
What is the test? Okay, so now we got to go in and do this stuff again. Transform, automatic recode, state. Okay, so now we have the codes. So now we go to analyze. Here means this is a.
I think this is hold up. Yeah, I think you're right. I think this is I don't want for two means pair data.
So we have two different groups that we're surveying, and one group doesn't influence the other, does it?
No, it does not.
So that would be an independent sample t-test.
Correct.
Okay, so the test variable should be the state code, and freshman should be the grouping variable.
Shouldn't state be in there somewhere? Could this be a so go back for a second.
To here?
No. Yeah, do reset. Go back one more step.
Okay, so I'll just cancel this out.
Yeah, cancel this out.
So
pair means a part of me wants to say this is paired samples t-test.
I don't think I've ever used that one before.
Okay, then let's do independent. I think you're right. Just ignore me. Sorry.
I don't think I haven't used that one in any of the homework
to
this point.
You're right. I'm like, yeah, they want to introduce something like for the first time, but wouldn't the grouping variable be state though?
The grouping?
Yeah.
Oh, yeah, because that's the one that changes.
Yeah.
Whether how many do it in one state or how many do it in the other.
Yeah. So I think the test variable would be freshman.
They're all freshmen.
Yeah. Okay. Well then.
Is that maybe you're right. Oh, wait a minute.
Yeah, because I think because those are the numbers.
The freshmen are in the group.
Okay. And then
I believe they're the group.
Okay. And have we done an automatic recode for this?
Yeah.
Okay.
That's how we have this column here that says state code 2s and 1s, meaning Colorado and Utah, or Utah and Colorado. So what is the test variable? The variable is, I believe this number over here is one that changes. This number doesn't change.
Yeah. Yep.
That just refers to the state. So I think it must be the freshmen that go up there then. And the state code is the variable.
Yeah, that makes sense.
Does that make sense?
Yeah, because we're putting the groups together based on whether they're a 1 or a 2, and we're testing them based on the variable number. Okay, that makes sense. That makes sense to me.
Okay.
And the cool part is if we get it wrong, we know it's wrong.
Okay, so there's our info.
Awesome.
And we want to know, let me get this over here.
What is the test statistic? The test statistic is negative 0.845.
Test, yeah, negative 8. Oops, negative 0.8.
Mm-hmm.
Okay.
And do we half the do we half it this time, or do we not half it this time?
This is, we half it because this isn't, yeah, because you make that determination based on the alternative hypothesis.
Okay.
Right? Because this is always the same thing. The null hypothesis is always this equals that, until you can prove otherwise. So the null is not equal to, could be greater or less than. So I think you half this number.
Okay.
So, oh, shoot, I'm not writing down the answers.
So, yeah, how you doing?
13, negative 0.845. I'm recording all of our answers.
Cool.
We have, let's see. Okay. So, what did you get for the?
So for the p-value, if we're halving it, I'm gonna say that it's 0.205.
That's what I'm saying.
And then I think it would be failed to reject the null.
Okay, so 0.20 is a lot bigger than 0.05, and I believe that's what we're working on.
Yeah, the problem is that's like suspiciously higher. Suspiciously higher than it. So it seems like we've just been getting really high null hypothesis. So I'm like, or high p-values.
We've only got a couple more questions to go to find out how amazingly well we did.
Oh, here's the optimistic. Yeah.
Now determine the margin of error for a 95%. We do have a 95%.
Okay, the margin of error.
I don't know the answer to that one. I don't know which.
Okay, so I think that will be that'll be what we did a little while back.
What was that? What do we do?
Margin of error. Okay, so So this would be the point estimate. So I'm pretty sure it would be x bar minus z plus sigma over the square root of n. For the low, and then for the high, it's x bar
They
plus.
want us to do math.
Yeah, maybe.
Okay, so the confidence interval,
Yes.
the margin of error for this is determine the margin of error for this confidence interval. Okay, so the confidence.
So because I know some of this, it's gonna be Right. Okay. So also
Oh wait, the margin of error
is
is
z
equation.
times. Isn't it z times sigma? Okay, no, I was looking at the point estimate. So wouldn't it be z times sigma over the square root of n?
Just a second, I got to see what I have in my notes because I think you're right.
Because we have z, I think.
Okay, mean population variance z. Huh. Why can't I find it? Oh, here it is. I think. Margin of error. Wow, why can't I find my. Okay, that's t distribution, degrees of freedom, confidence interval. Required. That one's test value. Simply. Okay, so what did you say it was?
So I'm thinking it's gonna be here. Like, let me calculate it real fast.
Oh, here it is. Margin of error.
Yeah.
So that's
Yeah. So I'm thinking it's z times sigma over the square root of n.
what I think. Yep, that's what it is.
So what? Okay. So z is
1.96.
there we go.
And sigma. What is sigma? Sigma is. What is sigma? I'm completely blown a gasket here.
How,
Well, the sample standard deviation. Okay, so that.
sigma would that be 0.410?
No, that's the p value.
Okay.
It must be the standard area is different.
Standard error difference. Okay, yeah, that makes sense. So that would be 1.73630. Cool. And then n is our size. What is the sample size?
Must be 22. 10 from Colorado.
So 22.
Do you hear that? Echo?
Yeah, I think we have a bit of an echo.
It wasn't going on before.
I thought I noticed it because I'm not getting an echo on my end. I think the echo is coming from your end.
So what am I doing? Oh, you know what? I think. A second. Does that make a difference?
Yeah, I think it makes a difference. Yeah, hang on.
I don't know what to do.
How bad is it?
If you can't hear it, and it doesn't annoy you, I can handle it.
Okay. Yeah, it might be a good idea just to power through this. I'll keep talking to a minimum. Let's do the equation and then let me know what you get.
Okay.
All right, let me know when you're ready.
I have 0.726.
0.7. Let me calculate it to double check. So I got the same thing you got.
Now there's another possible for this. What is that? This would be different. So there's also confidence. How do I put this?
See, that was the first thing I suggested, and the confidence interval is here. Give me 1 second. I'm gonna try something on my end for you. Okay, did anything work?
I think so. I still hear me.
Okay. So it's still going.
Yeah.
I'm sorry. Okay. Okay.
Well, let's just put that as our answer.
Yeah, but we have to do the confidence interval for the upper and the lower bound.
Okay, and that shows on SPSS.
Cool.
So the lower is negative 5.3. No, is that right? 5.37.
All right, so I'm going to submit.
Just a minute, I'm not. Yeah, go ahead and submit.
Yeah, I'll submit and let you know how it goes. Ah, dang it. Yeah,
we suck.
No, not necessarily. We missed 4. We missed 4. So we missed 14, but we got the other ones right. So we got 14. We missed question 11, so it was not C. We missed 9. And that was one. That was when we were like, well, we know what we did wrong.
Yeah.
So that's good to know. Here, and you said you wrote the answers down.
I did.
Cool. So I'll just.
What's the other one?
The other one we missed. So okay, let me go through it. So we got. We missed question 9.
Yep. Got that one.
Yeah, we missed question 9. We missed question 11. We missed question 14. Question 16. Wait, hold up.
That's 4.
Yeah. So that's 4. But have you ever looked into the view feedback for the ones you get?
No.
I just clicked on it, and it actually gave semi-beneficial stuff. Okay, so I'm not sure.
Where does it save you?
It's just when you answer it, when you submit them.
Oh,
You'll have them wrong. But it says the answer in SPSS is slightly lower than in Excel. So the answer given is the average between the two results. Your result should be closer to the answer shown, but it's not showing me an answer. Hold up. Yeah, okay, never mind. It completely ignored the feedback. It is useless. Yep, so you got those 4?
I got them down here. So if I haven't submitted yet, so let me go back to number 9. And then I'll submit. So that one we need to have. I said we didn't.
Yeah, I'm thinking it's going to be 0.333.
Okay, I'm going to change it.
And then for 11.
Okay.
11 is messing me up.
Wait a minute. It should be D.
Should be D? Okay. I back that idea.
Okay, let's change that. And then number 14.
Maybe we weren't supposed to half that one. Maybe we were supposed to go.
Leave it. 0.410.
Yeah. That might be.
Okay. We'll go with that. And number 16.
16, I honestly don't know what we did wrong.
Yeah, that one is an unknown.
Yeah, that one's kind of. So do you want to try and power through that one, or do you have things to do?
No, I can look at this one again.
Wait, which one?
We can look at 16 and see if we can do it the right way.
Cool.
So maybe we use a different formula that is x bar negative z. Wait a second.
The thing is, though, is that's the confidence interval formula.
Yeah.
So that's not the. So margin of error is z times sigma divided by square root of n. So that's the only thing we have. So it has to be that answer, or we're calculating it incorrectly, and you and I just so happen to have made the same calculator mistakes.
Okay, let's try again. So I'm wondering if the number we're putting in on top or sigma is wrong.
That would okay. So I could see that. I could see that being our problem. What if it's next to the t? So what if sigma is 1 or 0.185? So you see that?
Where do you see that?
So
Sig?
yeah, there's not one at the bottom.
We don't use anything on the top row, though.
Okay.
Only use thing on the bottom.
Well, there's my bet.
So up here we've got standard deviation for both variables.
Okay. Oh, hold up. I haven't done this before, so I don't know if this is crazy or smart. But what if we were to get the mean between those two? That doesn't seem like it makes sense, though.
Well,
I mean, did you read anything in that in like the textbook?
I'm at a loss.
Yeah.
Let's just move on.
Okay.
Just leave that as it is and see how we go. Okay, so I'm going to submit.
And then I'll bring that up with my tutor tomorrow. I'll even make a note of it.
Okay. This time we got 16.5 out of 19. So
Okay.
we missed 17. How did we miss 17? Oh, that's my fault. Dang it. I put it in wrong.
Well, the cool part is you get to take
Right.
You've got one more, so that's fine.
We missed 16, obviously.
Cool.
We got 14 right by changing it.
Okay.
We didn't get 11 right.
So it's not D.
Yeah, it's not C or D. So it's either A or B.
Okay.
And then number 9, we got that one right.
Okay. Here, I'm gonna retake or restart it. Can you read them off to me?
Yeah.
So give me 1 second.
I only started at 6. So let's see, but we got everything right.
Yeah. Give me 1 second. So 3 is A and B.
Right.
4 is a T score.
Yes.
5 is B.
Yes.
6, which one's 6?
6 is 37.996.
0.996. Cool. 7?
Okay. 206.637.
And what is 8?
Negative 0.4.
I'm sorry. Negative 0.434.
Right.
9.
0.333.
10 is fail to reject.
10 is fail.
Okay. 11's D.
Yeah, 11's A or B.
Oh, A or B. Okay. Oh.
It must be B.
Okay. We
No, wait a
have
minute.
insufficient evidence that the mean dentist bills between.
Right, yeah. So that's
Okay, that does make sense. Okay. I mean, fail. 12.
The first two made sense to me as well.
Yeah, I just.
I mean, that was right. That one's got to be right.
It does. It does. If it's not, then I'm just. I don't know.
12 is B.
D.
Does
Okay.
not
13.
negative 0.845.
14.
0.410. Or point. It only ends up as 0.41. But that's okay. Sure.
Yeah.
15 is
16
fail.
is- Okay. 16, we're just giving up on. Lower bound is 0.7. What is it?
17 is negative 5.137.
Okay, so negative 0.
Wait a minute. Hold it.
Oh, hold up.
No, that's right. That's right. You put it wrong.
What is 17? Negative 5.
0.137.
Okay.
And 18 is 2.204.
Okay. So I'm going to submit, and I'll let you know if anything changes. Yes, question 11 was B, so that's cool.
All right.
So we got all but 16, which I'm totally happy with.
Yeah. Cruising. Okay. Good job.
Awesome, Don. So what do we do in terms of turning in the video now?
You post that to the discussion board. It's called the collaborative discussion board or something. Post the link.
Okay. Cool. Well, thanks, Don.
Okay. Take care.
Good night. Yeah, you
Good
too.
night.
All right. See you Tuesday. Bye.